And welcome to the fifth lesson on the interest and depreciation series. We're on lesson 5, which is on depreciation. Just really quick, wanted to make a note that this section that explains what depreciation is can be found on the 13th page of the work booklet. It's a small section that's under an Excel task about repeated application of simple interest. So just to quickly read out what it says, depreciation is the loss in value of something over time. What kind of things lose value? Well, the most common one that we think about are vehicles, so cars, vans, boats, but also machinery, equipment, things like that. This can be pretty important to you as usually if you run a business and you have to buy items for that business, if they lose value, that can be put towards your tax return at the end of the year. So understanding how much your machinery is worth could save you thousands of dollars in the long run. So definitely something you should be looking at. So as it says, there are two types of depreciation. One is straight line depreciation. What this means is the item loses a constant value each year from one year to the next. So something like $1,000, $200, $10,000, etc., etc. And the important part about it is that if you draw a graph of the value of the item over time, you are going to get a straight line, a linear function. Funnily enough, that's why we call it straight line depreciation. The vertical incept is the initial amount that the item is worth, calls it the new value here. The gradient is the negative of the annual loss in value. In other words, if your gradient is minus 300, it means that it's losing $300 per year. The other type of depreciation that we get is declining value depreciation. In this case, the value of the item goes down by a percentage of its value each year. So for example, it could lose 15% of its first year value in the first year, and then 15% of that new value in the second year, 15% of that new value in the third year, and so on and so on. When we draw a graph of the value of the item in this case, it's an example of what's called exponential decay. It's graphed with a smooth curve. You'll learn a little bit more about this next year, as it says, but just to give you a rough idea, and that is definitely the worst vertical axis, just to give you a rough idea, what we're looking at, if that is the value over time, we're going to get something that looks like this. Sorry about the really bad axis there. It's okay. So we'll examine that a little bit later. So this lesson is just going to look at the first one that we mentioned, straight line depreciation. So if you turn the page for that first part. Over the page, we have got the title Straight Line Depreciation. Straight line depreciation occurs, as we said, when the value of an asset goes down, depreciates by a fixed amount each year. The formula that calculates the salvage value, i.e. how much it's worth later on if you are trying to sell it, which we're going to call S, of an asset, so a physical thing, is S equals V naught minus D multiplied by M. V naught is the purchase price of the asset. Why do we use V naught? Well, it's the value when the time is naught. You may remember from compound interest, we said the value of something after n time periods was a to the n. So this is a kind of example of that. It's after no time has elapsed, it's right at the start, so it's kind of the equivalent to an A naught. But it's not a deposit, it's the value of something, so we're using a V instead. D is the amount of depreciation each time, and N is the total number of time periods. Make sure the time periods match up with how often the depreciation happens. It tends to be that they do, but just check. So if we want to calculate any one of those values, what we're going to do is substitute in the values that we do know, so all known values, and then solve the equation that's formed. That's why we solve equations quite early on in the year, so that when we get to these more complicated scenarios, we know what to do. Okay, so let's scroll down, have a look at the first example. Tom buys a car for $58,000. It depreciates by 40% in the first year. So calculate the salvage value of the equipment after 1 year. Well, if it goes down by 40%, let's find out what that 40% is equal to. So if we want 40% of something, we can find 40% means 40 for every 100 and multiply it by the 58,000. Depending on what you've done with the formatives, you instead may use 0.4 times 58,000. Either way, both times you are going to get that is $23,200. So that is what our depreciation is equal to. The salvage value then is the initial value of 58,000 minus 23,200, the amount of depreciation, times by 1. It's only happening for one time period. You can put that into your calculator, and that is 34,800. We remember the units are dollars, so we take care to write in the units as well. Okay, so that's a nice straightforward one. In example 2, it says a laundry buys dry cleaning equipment for $30,000. The equipment depreciates, goes down by a fixed amount of $2,500 every year. So if we want to calculate the salvage value of the equipment after 6 years, we put it into that formula. We say that the salvage value is equal to V0, the initial amount, 30,000, minus the amount of depreciation, 2,500, multiplied by the number of time periods, multiplied by 6. Once again, just put that into your calculator, let that work it out for you, and you should find that you get $15,000. Okay, so that's one nice and straightforward. There we're just finding a salvage value. We just have to put in a sum. There's not too much working out to be done. Number 2 is a slightly harder one. It's an equation that we need to solve. It asks us, when will the equipment be worth a third of its purchase price? Well, first off, what is that salvage value when it's a third of its purchase price? So it's 1/3 of $30,000. So we want to know, when is the salvage value equal to 10,000? So we need to put this information into the equation and solve it. We want to know S, 10,000, is equal to V0. What was V0? We substitute that in. V0 was, of course, $30,000. Minus the depreciation, 2,500, times by n, the number of time periods, which we don't know, so we have to leave as n. Okay, so depending on how you like to solve equations from what we started with, remember the main aim is we need to find out what is the value of n, what's this equal to. So we get rid of the other things that are on this side of the equation until we've just got n. The way we do it is by changing both sides of the equation. So to start with, let's get rid of this $30,000. So we're going to take away $30,000 from the right hand side. We also then have to take $30,000 away from the left hand side. That will leave us minus $20,000 on the left is equal to minus 2,500 times by n. This is n multiplied by 2,500, well, by minus 2,500. So to find out what n is, we need to divide it by minus 2,500, because multiplying by minus 2,500 and dividing by minus 2,500 will cancel out. We then need to do that to the left-hand side as well. So if you change one side of the equation, you have to change the other side. When you put that into your calculator, you get 8 on the left is equal to n. So what were we measuring n in? We were measuring it in years. So the amount of time it takes for it to be worth a third of its purchase price is 8 years. And that's our final answer. Okay, if you turn over to the page, there is a graph that we need. The third example shows a table of values for the value of a pleasure boat cruiser. This is showing after how many years. So in the first row, after 1 year, that it's worth $180,000. After 2 years, it's worth $160,000, and so on and so on. You may want to quickly check for yourself that you can understand that the amount of depreciation is equal to $20,000 every year. So if we scroll down, we have got a graph that we need to fill in. We need to fill in this graph to show the value of the boat over time. What you should do is plot the points that it gives you. So it gives you 200,000 is its starting value. After 1 year, it's worth 180,000. So we've got 1 year at the bottom and then 180,000 at the top. After 2 years, it's worth 160,000 and so on. As before, try and plot at least 3 or 4 points so that you can make sure that they all line up and you've not made a mistake with any of them. Okay, so I'll do my best to join these with a straight line. As you can see, it just goes from the top corner of one box down to the bottom right corner. We're going to extend that line. Hopefully you've done better than me with a ruler. That's not too bad. And then some questions about this graph are on the next page. So turn over to the next page. On this page, it's got 2 questions about the graph. The first one asks you to estimate the value of the boat after 8 years. What I'll do is I'll just give you a second to turn back to your graph, find 8 years. When you found 8 years, go up that vertical line until you meet the graph. Mark that point and then look to the left to see the value at that point in time. Hopefully, you should have found that the value of the boat after 8 years is $40,000. Part B works a similar way. So if you just want to quickly turn back on that page, it asks you to work out when the boat is worth approximately $50,000. $50,000 is halfway between 40 and 60,000. So you might want to draw on an extra line with a ruler to help you work this out. But as you can kind of see that it goes from one box to the next at a time, because it's halfway between the 40 and the 60,000, when you go along, meet the graph and read down, it should be halfway between the 7 and the 8 as well. So what does that mean? Well, it means that it's after 7.5 years that it's worth $50,000. Okay, so the rest of the lesson should be on exercise 805. As always, the questions to do are in your workbook. Let me know if you've had any questions about the video or if you've got any questions about work.